Hello, this is the video for Chapter 9, Lesson 2. So in this lesson, we're really going to get started on graphing our quadratic equations. So before we start graphing, let's fill out some of these notes. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c that equals 0, where a does not equal 0. This form is called the standard form of a quadratic equation. So we've been talking about how there's a special type of equation right here in this form that we can create a special graph. So when we graph these, there are three types of graphs that we'll see. The solutions of a quadratic equation are the x-intercepts of the graph, aka the roots of the equation. So the solution of the equation is where it crosses over the x-intercepts. And it's called the roots of the equation or the zeros of the functions. So when we graph these equations, the three types of graphs that we'll see is one, no solution, meaning when you create your quadratic equation or your graph, your parabola, the solutions or what we see of where the intercepts are is exactly on the x-intercept or the x-axis, okay? And so this would be where there's one solution. So I'll kind of compare that to two solutions here. These are separate graphs. So look at these separately. This would be where it's crossing over the x, exactly on the x-intercept. And then this is one where it's maybe going the opposite direction and it's crossing, it's touching the x-axis at exactly one point. So these are two separate graphs. Imagine them being on two separate graphs. These are both examples of one solution. Then two solutions is where when you have your parabola and it cuts through that x-axis twice. So one parabola is intercepting that x-axis twice. The no real solution would be an example where your maximum or minimum of the parabola does not even cross over the x-axis at all. It like never touches the x-axis. And so this would be an example of no solution. So where you're looking for the solution is really where it's most likely, where is it going to cross over on the x-axis? And so in this case, it's the minimum and maximum, no real number solution. The maximum and minimum never crosses. And then for the solutions, two solutions, it's that graph is just cutting through, on both sides there. So let's practice graphing. Now, there's a few things that we have to think through when we're graphing. And because there's, it's different from a line where there's more things that we have to think through. We have to think about where is maybe the y-intercept, and then where is the axis of symmetry, and where is the maximum or the minimum. So the first thing we're going to do is find the axis of symmetry. That's always going to be the first thing. So the axis of symmetry is always going to be negative b over 2a. So we'll look at our equation and we're looking for where b is identified. This is -4, and then a is at 1 basically. So we're going to write this as -4 over 2 times 1. And when we divide, we basically have 4 divided by 2, and that is 2. So the axis of symmetry is cutting through the x-axis at +2. And I recommend every single time you do this, draw that dotted line across vertically, cutting through +2. So really what this is saying is x equals 2. That is the axis of symmetry. Now, once you know the axis of symmetry, we know that that maximum or the minimum has to be on that line, on the axis of symmetry itself. So we can actually replace all the x values in our equation with 2 and see what our y will equal. So to find the vertex, we are going to plug in 2 squared minus 4 times 2 plus 3. And when we plug that in, whatever we find equals y. So we plug that in real fast. And we have basically 2 minus 8 plus 3, which ends up being -1. So that means our vertex is at 2 for the x-axis and -1 on the y. So 2, -1 is our vertex. 2, -1. That is right here. And we can predict that our graph is going to be pointing up because this is a positive. So remember, when we have a negative ax squared, then it points down. And when it's a positive x squared, it points up. And so in this case, we can kind of imagine our graph is going to curve upwards. Now, another important thing is identifying the y-intercept, and that's always going to be c. So c is at +3, which means I'm going to put +3 here as a point, and then I'm going to mirror this over because I can see that this is, my parabola has to be mirrored on both sides. I'm going to count 1, 2 over from the axis of symmetry and then go 1, 2 over to the right. And if I wanted to connect these points, I could. Now, I would recommend when you're graphing, always graph 5 points. It's going to give you a more accurate line. So let's just make a little chart real fast. And you just need 2 more. Honestly, if you even just put 1 more point on here, like I could maybe put, where would my point be if it was like at +1 on my x-axis? So I might put 1 in place of my x, and then I would plug in my equation. So that'd be like 1 squared minus 4 times 1, which is 4, plus 3. So 1 squared is 1, 1 minus 4 is -3, -3 plus 3 is 0. So that means I have a new point, 1, 0, that would be right here. And you could actually just directly mirror this over if you wanted. That would give you that other point, but we could always mathematically just check our work to see if that's right. And so this would be 3 squared minus 4 times 3, which is 12, plus 3, and then we could work that out. And it does actually end up equaling 0, 2. And so it just so happened that I found the 2 solutions for this equation, or what we call the roots of this equation, is the x-intercept intercepting the x-axis at 2 locations, one at +1 and one at +3. And that was just by chance. You could pick any number for the x, and then plug that in the equation and find a new point, and then graph it on your line. So looking over here, let's review what we did earlier. First step is find the axis of symmetry, which is -b over 2a. And then negative -2 times 2 times 1. So that's 2 divided by 2, which is 1. So my x-intercept, or my, sorry, axis of symmetry is going to be at +1. And then I'm going to plug in 1 squared minus 2 times 1 minus 8 to solve for y. When I plug this in, I get -9 equals y. Okay, so that's way off my graph here. I mean, I'm going to still graph it anyway. See if that, so 7, 8, 9. So it's going to be like somewhere down here. I'm going to use green. That's going to be where my vertex will be. So my vertex would be 1, -9. And then again, I would just to be careful, just pick 2 more points. I mean, right now, I actually only have 1 point. And then my, it looks like my x-intercept is at -8, which is also not on my graph, but it's going to be like somewhere right directly above here. So let's do 1 more point, especially because it's like, let's do something, maybe let's ask like, where would it be if I put a -1 as my x? So then this would be -1 squared. Remember to put that in parentheses, minus 2 times -1, which is -2. So we're going to add 2 minus 8. That ends up being -5. So my -1, -5 would be there. And then I could go 1, 2, mirror it across, 1, 2. And so your parabola, draw it well, is going to look something like this. And it should cross over on my point right there. But I could, plug in +3 just to check mathematically to see if that works. And I should also get -5 over here as well. So recommendation is, other than just finding your vertex, axis of symmetry, and y-intercept, find 2 more points to graph. Use 5 points on every graph to make it the most accurate that you can. Okay, here's problems with one root, meaning that the graph is intercepting the x-axis at just exactly 1 point. So if we look at this original equation we're given, it's not in the form of ax squared plus b plus c, bx plus c. So I need to rearrange this. I need to just rearrange this so that it is in that form, because that form, the a and b and c, have to be in a specific order to tell me specific things. So I'm going to subtract 10x on both sides and put it in the middle. And then I'm going to leave my 25 over where it should be, and that equals 0. So now my equation is x squared minus 10x plus 25. This is what I want to look at. Now, you can already see this plus 25. That should be my y-intercept. I'm not going to be able to graph that, but that's okay. Let's start with other things. So let's do our axis of symmetry, negative b, which is -10, over 2 times a. That ends up being positive 10 divided by 2, which is 5. So I have an axis of symmetry at 1, 2, 3, 4, 5. And this graph should be pointing upward. Now let's find where the vertex is. So the vertex will be 5 squared plus, or actually minus, because I'm using the equation that I recreated, minus 10 times 5 plus 25. So 5 squared is 25. 25 minus 50 plus 25 is 0. So my vertex is at 0, which that kind of lines up with this type of problem. It should have only one root anyway. And then again, we need to find 2 more points. So I might just go directly above a little bit. Like I might see where 4 ends up being. So I'm going to put 4 here. And this would be 4 squared minus 10 times 4, which is 40, plus 25. And so let's plug that in. 4 squared is 16. 16 minus 40 plus 25 is at 1. So my y would be 1. This would be at 4, 1. And then at mirror it over, it would be like that. And so I could graph my thing. And these, I think it's a little harder. If you don't have a y-intercept, I'm going to allow you to just use the 3 points. Okay, over here, axis of symmetry. I'm looking at my equation. I have to rewrite it. So it's x squared plus 8x plus 16 equals 0. And so this is going to be -8 over 2 times 1, which is -4. So -4 is over here. 1, 2, 3, 4. My axis of symmetry. And then I'm going to guess that my vertex will be on the x-axis, but let's just double check mathematically. So -4 squared plus 8 times -4 plus 16 equals y. -4 squared is 16. 16 plus -24, I think, or 8, no, 32. 8 times -4 is 32. -32 plus 16, that will cancel out. It will be 0. So again, this is where my vertex is. And then let's just pick 2 more points. So I know it's going to point upward. I might just take a look at like where would it be where negative x would be -5. And so my equation will be -5 squared plus 8 times 5 is 40 plus 16. So this should be, actually, there should be -40. So I can write this should be -40 minus 40 because of that -5. And that gives me a +1. So +1, and now I change colors here. And then I'm going to mirror it over. And there's my, your graph should look a lot better than mine because you're doing it on pencil and paper. Okay, last two problems here. Again, let's rewrite these equations. So bring this over. -x² minus 3x minus 5 equals 0. Now it's -x². This has no real roots, meaning I don't think I'm going to have a vertex that's going to be on my x-axis. Let's just double check. So axis of symmetry, -b, which is -3 over 2 times -1. 3 over -2. I divide this, it's -1.5. Okay, so my axis of symmetry is actually -1.5. It's in the middle here. And sometimes when you graph, you're not going to have perfect numbers, and that's okay. Then we're going to plug in our x to find our vertex. So be careful here with these negatives and these decimals. So -1.5 squared minus 3 times -1.5 minus 5 equals y. I'm going to plug this all in. Once I've plugged it all in, I get -2.75. So my vertex is at -1.5, -2.75, which is somewhere right here. Close to the -3, but not quite there yet. And then my y-intercept, if I look up at this, tells me it's at -5. I'm going to put a -5 here. And then I'm going to mirror it over. And it's going to be over mirrored on the other side. Then we could pick 2 more points. Let me see where -1 would be. -1. So again, be careful with these negatives. -1 squared. So -1 minus -3, so +3, minus 5. And that gives me -3. And rewrite, your equation, everything here. -3. So that's -1, -3. That's like right here. And that means my other point is going to be mirrored directly across. And you could, plug in that would be -2 and see where would that end up being. And it should also be at -3 if you plug it in. Last one here. This is already in the correct format. And first step, let's write our negative b, right? -4 over 2 times a. And a this time is at 2, +2. This is 4 divided by 4, which is 1. So my intercept is at +1. And then let's write our equation 2 times 1 squared minus 4 times 1, which is 4, plus 5. And 2 times 1 is 2. 2 minus 4 plus 5 is positive 3. So my intercept, or my vertex, is at 1, positive 3. Then let's pick, well, let's actually look at our intercept. Our intercept is at positive 5. Then me over here, mirror to the other side, over here. And I am kind of out of room on this graph, so I'm just going to let this one slide. And let's just say, let's pick 3 points. We could probably pick like, where would, 0.5 or something be, or 1.5. But if my graph is a little bit longer, I might pick like -1 and positive 3 as like an intercept and see where that would end up. But it might be like all the way up here. So we're just gonna be okay with this one. But that's basically, remember, the 3 main things is really find the axis of symmetry, find the vertex, and then use a t-chart and plug in 2 more points, as well as plotting your y-intercept. If you can do those few things, you'll be able to graph with no problem.